Welcome back. The objective of this video is to look at what is deferred annuity and looking at how we can calculate it. Okay, so we'll do that and we'll finish up with an example going through the steps. Okay, so an ordinary annuity is as shown here, okay, where we are at time 0 and the first annuity payment is 1 period from now. Okay, if that is the case, we can just use the equation that I went through in the last 2-3 videos. Okay, but a deferred annuity is a situation where the cash flow looks something like this, where the first annuity payment is not until several periods later. So in a situation like this, we can't just straight away apply our annuity formula because it's not what we initially assumed. Okay, so this is essentially what a deferred annuity is, and now we're going to look at an example of how we can calculate it, as well as go through the steps that is involved in working out the present value, so the value at time 0 of such an annuity. Okay, so here's just the previous example where we actually put a bit of numbers in. Okay, so we want to work out the present value of the annuity where the first annuity payment starts in year 3. Okay, so the first thing we need to do is find the present value at year 2. Okay, so we know that we can apply the formula if we start the annuity 1 period from wherever we calculate it. So in this example, if we calculate the annuity at this point, we can just straight away apply the equation because 1 period is when the annuity starts. So what we're going to do first is find the present value of this annuity at year 2. Okay, now if that's the situation, we can apply the formula or use the table. So I have done that very quickly as shown here. We know our annuity is 50, we know our interest rate has been assumed to be 10%, and we know that there are 1, 2, 3, 4 periods, so therefore we can work out a present value at time 2 to be 158.49. Okay, so exact same thing as if we were to use the interest rate table. We're trying to find P given A, I, and N. We know our I is 10%, we know our N is 4, and using our interest rate table, looking at the column that says finding P given A, I, and N, we worked out the factor to be 3.1699. So all we do now is just times the annuity amount by 3.1699, and we find that the present value at 2 turns out to be exactly the same as previously, 158.49. So at this present moment, we have only found the present value at year 2, but what we actually want to do is find the present value at year 0. So the next step we're going to do is say, alright, well, this is technically a future value in respect to time 0, and all we're going to do is just discount this back to year 0 and we're finished. Okay, so this is what we want to do in our next step. Okay, so at the moment we have PV2, which means we know the present value at year 2, but what we actually want to find is the present value at year 0. Okay, so we know this is a future value, so we can use the discounting formula. So present value equal future value divided by 1 plus r to the t. Okay, this is just the discounting formula that we shown in the first 2 videos. Okay, so if you don't remember that equation, I suggest you to go back and have a quick look at the first 2 examples, first 2 videos. Okay, so once again, all we have to do now is put in the values that we know. We know at year 2, the present value of the annuity is 158.49, and we know the interest rate is 10, and we know the period here is not 4 but 2, because we are at this point and we want to go back to time 0. So that's 1 period, 2 period. So here you got to be careful to recognize that we're no longer dealing with the annuity. We already know the value of the annuity. We just want to convert it back to present value. if we were to do that, we get our present value at time 0 to be 130.99. Okay, we can do the exact same thing with the interest rate table. Okay, so the present value at time 0 equal the present value at time 2 times this factor. Okay, so we know I is 10, we know N is 2, and therefore we can look in our column that goes finding present value given future value I and N, and we show that this factor is 0.8264. Alright, so all we do now is, as have we done all the time with the interest rate table, we go the future value, which is the present value at 2, which is 158.49, and we times that by the factor, which is 0.8264, and we get the exact same answer of 130.98. Alright, so in this example we have shown how to deal with a deferred annuity, and in particular we looked at the idea of having multiple present value. So we find present value at particular time, and we are going to be able to manipulate these present value position to work out the value at any point along the cash flow diagram. So for example, if I want to work out how much this annuity worth is here, how much the annuity is worth here, we can also find out a future value of this annuity anywhere along this line, along the 4 annuity payment, as well as some period maybe here at year 10. We can show how much is these 4 annuity values are worth at year 10. Okay.